Okay, just to make this clear, I'll rewrite this as 1 over 4. Yeah. So now we have to write 5.3. 5.3 says that Andrew has no idea how to draw the graph of the inverse. So you need to explain how he may use the graph of f to draw the inverse of f. So what you can say to Andrew, a hypothetical learner, is that what we can do, we can say that f of x is symmetrical about the line y is equal to x. So you need to reflect the function f of x along the line y is equal to x. That's how you can explain it. And I can see that 5.4 is asking for us to do that, to do exactly that. So what you can say is that the inverse of f is symmetrical, right? Symmetrical to the function along line y is equal to x. So what Andrew needs to do is to reflect the graph f along y is equal to. Then question 4 or 5.4. Hence or otherwise sketch the graph of f. Then for us to sketch the graph of f, we need, or the graph of the inverse, we need to sketch the graph of f as my Cartesian plane here. And you can see that the graph of f will have a y-intercept at 1 because it has a proper fraction, or the number that is raised to the exponent x is a fraction, is a proper fraction, or is between 0 and 1. Then now we know that our function is going to decrease. So this is our function here, and this is the graph of f. Then what we need to do now, we need to reflect it along the line y. So this is the line y is equal to x. And if you reflect this function along the line y is equal to x, it will be like this. And then now it will have an x-intercept of 1 and 0. So the green line is our inverse function. So that's how simple it is. Then we can go to the next question. The next question says that we must write down the domain of the inverse. Now you remember, the domain of the inverse is all x values of the inverse, and you can see that there's no x value that is negative, so meaning that x is greater than 0. Very simple. So you remember how you read a function, you go from left to right, and then there's no x values that are negative, so meaning that any value that is greater than 0. 5.6. For which values of x will the inverse of f be greater than -2? Now this is f of -1, x is greater or equal to -2. Now what we need to do now, we need to write down the function of the inverse, which is log 1 over 4 x, and we cannot use exponents and logs with greater than and less than, so we need to say equal to -2, and then now we know this is the exponent and this is the power, and then 1 over 4 is the base. So what we can do, we can revert this to exponential form, which would say that x is equal to 1 over 4 to the exponent negative 2. Now remember, exponential function in exponent form. So we have what? We have a base raised to an exponent. So this is exponent form. Exponent is equal to a power. Then in log form, we have the exponent is equal to the log of the base, and then we have the power over here. So now we are interchanging this notation here. The first notation here is log notation, and then here we have exponential notation. So now when we change from log to exponential, this is what we can do. We can say that x now is equal to 16. So the x value is 16. So meaning where x is 16, y is negative 2. And we can see that negative 2 is somewhere here. This is negative 2. And then over here, x is 16. Then now the question says, for which values of x will the function be greater or equal to negative 2? And you can see that it's this area here. Let me just use a highlighter. It's this area here. It's this area here, and you can see that the x value is between x is equal to 0 and x is equal to 16. Remember, because of the asymptote, we cannot say that x is equal to 0. So meaning that our answer now is going to be x is between 0 and 16. But we can only attach the or equal to at 16 because we have an asymptote there, which is y is equal to 0. So that's very simple. The next question is 5.7. For 5.7, we have q is equal to 1 over 4 log 1 over 4 1 over 2. So you remember, we have y is equal to log 1 over 4 x. So meaning over here, our x value is equal to 1 over 2. And then we need to find q. So now if we press our calculator now, q is equal to log 1 over 4 and then 1 over 2. This will give us 1 over 2. So meaning that where the x value is 1 over 2, the y value is also 1 over 2. So meaning the x value is 1 over 2, and then the y value is also 1 over 2. So we have something like this. And then the next question is asking hence or otherwise, meaning go back to this question. Hence or otherwise, determine the coordinates of the point of intersection of f of x and g of x. Now, if you look at f of x here, which is, this is 5.7.2, f of x is equal to 1 over 4 to the exponent x. Then the inverse of the function is equal to the log of 1 and 1 over 2 here as your power. Now, or x, let me just rewrite it this as x. Then I'll go back to the 1 over 2. we can see that if x is 2 on this function, this would be what? Um, this would be 1 over 4 to the exponent 2, which is equal to 1 over 2. So we have a point 1 over 2 is to 1 over 2 at f of x. Then at the inverse of f of x, we have what? We have log 1 over 4 and 1 over 2 is our x value, which from the previous question is 1 over 2. So now we have what? We have 1 over 2 is to 1 over 2. And you can see that both functions have the point 1 over 2 is to 1 over 2. We have both functions have an x value of 1 over 2 and a y value of 1 over 2 at f. And then we have an x value of 1 over 2 and a y value of 1 over 2 at the inverse of f. So meaning that now these two functions intersect at what? At 1 over 2 and y is 1 over 2. So that was very simple. Let's look at our mark allocation. So we have 2 marks for finding the y coordinate of x is -2. So meaning that now we get a mark for substituting -2 and also 16 as our answer, which is 2 marks. Then the next question is we must find the inverse in the form of y. You get a mark for putting x and y, and then also you get a mark for converting to logs, or your final answer. Then for us to tell Andrew that the inverse function is actually the reflection of the exponential function along the line y is equal to x, we get 1 mark here. And then for the sketch of the function now, we get a mark for the x-intercept and the shape, so that is 2 marks. For 4.5, we get a mark for the domain of the inverse, that is mark. And then for 5.6, we get a mark for converting to exponential form and finding 16, we get a mark. And then also from writing the correct notation, we get a mark, that is 2 marks. Then the next question, or the final question, is question 5.7, which is 7.1. We need to find the value of q. So you get 1 mark for just pressing the calculator and finding q. And then the next question is question 5.7.2, where now you needed to state that the point of intersection is actually 1 over 2 is to 1 over 2. So you get a mark for the first question, or for the first response, to say that f of x at 1 over 2 at x is equal to 1 is 1 over 2. And then you get another mark for saying Guti f the inverse at 1 2 is also 1 over 2. Then you get a mark for saying Guti the point of intersection is 1 over 2 and 1 over 2, because it's a point that occurs in both functions. So that is 3 marks. So that is it for our exponential function. The next question is question 6, which deals with the parabola. Okay, so the next question is question 6, and we have a parabola over here and also a linear function. So f of x is the parabola, and then g of x is the linear function. 6.1, it's asking us to calculate the length of AB, and which is the length from here to here. And if you can see, these are what our x-intercepts, so we need to find the distance between our x-intercepts, and so meaning that we need to find the actual x-intercept. So negative 3x squared minus 9x plus 30 must be equal to 0, because at the x-intercept y is equal to 0. You can factorize this if you want, or you can use the quadratic formula. So if you factorize this, the common factor is negative 3, so we'll have x squared plus 3x minus 10. So this is minus 10, so this is actually equal to 0 if you want to factorize, because after taking out the common factor, we can see that the factors are x plus 5 and x minus 2, which is equal to 0. So x is equal to negative 5, or x is equal to 2. Now the distance between negative 5 and 2, so meaning here x is negative 5 and then here x is 2, the distance between negative 5 and 2, which is the distance AB, is actually equal to 7 units. So that is a very simple and straightforward question. Then we go to 6.2. 6.2, we want the coordinates of k, but if you can see at k, this is where the functions intersect. So this is actually the point of intersection. This is the point of intersection, and we know that at the point of intersection the two functions should be equal, so meaning that f of x must be equal to g of x. So f of x is the parabola, which is negative 3x squared minus 9x plus 30 should equal to g of x, which is negative 12x plus 12. Then now what we can do is simplify and then solve for x, so that we can get our x values here. I have negative 3x squared. Then if I take this this negative 12x to the other side, it's going to become positive. So I'll have negative 9 plus 12x, which will give me positive 3x. Then if I take the 2 to the other side, it becomes negative, so I have to subtract it from negative 12 in fact. So I left out the one here. So the negative 12, I have to subtract it from 30, which will give me a positive 18 is equal to 0. Then it's up to you again whether you want to take out the common factor, because there's still a common factor, but I encourage you to use quadratic formula to get the same answers. If I take out the common factor here, I'll be left with x. So the common factor is negative 3, so that will be x squared minus x plus 18 is equal to 0. So this is my so if I take out a 3 here, this is going to be 6. This is going to be 6, so meaning that now this is negative 6. In fact, this is negative 6, so meaning that if I take out a common factor of 3 here, it's going to give me a positive 1. Take out negative 3 here, it's going to give me a negative 1. If I take out negative 3 here, it's gives me a negative 6. So I'll have this as my standard form. And then now we can factorize using the product law. So this is going to be x minus 3 and x plus 2 is equal to 0. Then x is equal to 3, or x is equal to negative 2. Now there are two values here, and both of them are where the functions intersect, and you can see that the functions intersect at 2 points, and the x value here is a negative x value, so meaning this is -2, and then the x value at k is a positive x value, so we're going to say that the x value at k is actually positive 3. Then now we need to substitute the value of positive 3 at either f of x or g of x, because both will give us the same y value. So we're going to choose the easiest one, which is the linear function is equal to -12, and our x is 3 plus 12. So meaning that now we'll have a y value of -24. So meaning that the point K has the x value of 3 and the y value of -24. So very simple here. Then we go to 6.4. 6.4, it says determine the maximum length of CD. Before 6.4 we are at 6.3. 6.3, it says determine the values of x for which f of x is minus g of x is less than or equal to 0. So we need to find the values of x for which f of x minus g of x is less than or equal to 0. Now, for us to answer the question, we need to take g of x to the so that